So to continue on and practice one titration example, we're going to look at this sort of sample data. So for the reaction that we've already gone over, NaOH plus HCl makes NaCl and water. If you started off with HCl, a volume of 20 plus or minus 0.5 cm cubed, this would be the solution in the flask that's being titrated. So we don't know the concentration of HCl, but we do know how much we're starting with, 20 cm cubed. Then we are adding to that NaOH, and that NaOH has a concentration of 0.5 moles per dm cubed. And this is the volume readings for the burette for the NaOH. So what we care about is the change in volume for each trial. So in this one, we've got clearly 15.4 being added, 15.40. And in the next one, we've got, let's see, I can move that out of the way. We've got 14.9. And in the last one, we've got 13.8. I don't think I meant it to be 13.8. That's a little bit odd. So I think I'm going to modify my own notebook file. I apologize for that. I meant for this to read 14.8, if I can get back on the right track. There we go. Okay, so first thing to point out here is that the volume of NaOH added after each trial, we just did that. These are the cm cubed. The volume that we should use in our calculations is probably going to be 14.85, which, as we'll round off with uncertainty, is going to actually end up being 14.9. Now, here's why we're going to do that. The first trial, remember, is a rough trial. So this 15.4, notice it's pretty far away from these other two readings. It's also much higher than the other two readings, because in the first trial, when it's rough, you're much more likely to add too much of the solution in the burette, in this case, the NaOH. So the first trial never actually gets included in the calculations. We call this the rough trial. It's just, we still record it, but we don't use it in the calculations. These two are much closer together. They're within 0.1 milliliters of each other. So I've averaged them, but then I'm rounding them to the first decimal place. And the reason why is that if each one of these readings has 0.05 centimeters cubed of uncertainty, when I do a subtraction, I have to add the uncertainties together. So the uncertainty on this reading is actually plus or minus 0.1 cm cubed. And therefore, I have to round off my answer to the first decimal place. And so that's why instead of 14.85, it becomes 14.9 plus or minus 0.1 cm cubed. So I actually just did part C. I figured out the uncertainty, and I rounded based on that. Okay, so use the volume from part 1 to calculate the concentration of nitric acid. This should say hydrochloric acid. Okay, so if we think about it, what do we know about NaOH? We know that we added 14.9 cm cubed, that's our volume, and we know that the concentration is 0.5 moles per dm cubed. So the first step is to figure out the moles of the NaOH that we added. So, 1 second. Subscript that. So we've got our concentration, which is 0.5, and we've got our volume, which is 14.9 cm cubed, but it's important to be in dm cubed, so I've divided it by 1,000. So the moles, in this case, is 0.5, and I got my trusty calculator here, times 0.0149, and that's going to give us the moles equal 0.00745. Okay. Now these are the moles of NaOH. This is the concentration of NaOH. This is the volume of NaOH that we added, so we can be confident that concentration times volume gives us moles. So this is the moles of NaOH that was added. Now, the nice thing from our reaction is that in this first example, the moles of NaOH in this equation, when it's perfectly matched and balanced, exactly equal the moles of HCl. It's a 1-to-1 mole ratio. So we can use that and say that those moles are also is going to mean that it's a 0.00745 moles of HCl. So this is based on the 1-to-1 mole ratio from the equation. The moles of NaOH perfectly match the moles of HCl. And then from here, we can continue on with our calculations. Again, N equals CV. We don't know the concentration of HCl, but we do know the volume that we started with. The volume that we started with was 20, given to us here as part of the data. So the moles are 0.00745 moles. I'm going to divide that by the volume, which is 0.0020 dm cubed. I'm dividing N by V in order to get C. So here we go. So divided by 0.02, and we get a concentration of 0.3725, and that's moles per dm cubed. Notice I'm doing moles divided by dm cubed, so moles per dm cubed is my final unit. This is the concentration of HCl in our problem. Now, eventually we'd want to go through with uncertainties, turn them into percentages, and turn them back into an absolute uncertainty here, but for the sake of the video, I'm not going to do that. We'd probably end up rounding this to about 0.37 or 0.373 moles per dm cubed. But again, the steps are ignore the rough trial, use the accurate trials, and either just use what the value is or average them, and round according to the uncertainty. Use that volume that you figured out times concentration to figure out moles of what you added. Use the mole ratio to get moles of what's in the flask. And then use N equals CV to solve for the concentration of what's in the flask. And that's pretty much how any stoichiometric titration goes, and we'll do some more practice in class.